Hello everyone, welcome to My Math Teacher. In this video, I am going to solve question number 3 and 4 from the exercise 2.2. This is for class 9 students from NCERT syllabus. The chapter is polynomials. Third question is verify whether the following are zeros of the polynomials indicated against them. Now this topic is about zeros of the polynomial. Consider a polynomial x minus 11. Okay. Now I am taking this as p of x. The meaning is polynomial of variable x because the variable mentioned here is x. I have to make this polynomial x minus, which is x minus 11, to 0. The value should be equal to 0. So now what I am going to do is, in the place of x, I am going to apply a value. Instead of x, I am going to apply a value which is 11. Okay. So in the place of x, it is 11. Now it will be 11 as well. Minus 11. So what is the answer? Now 11 minus 11 becomes 0. Okay. Now the polynomial of variable x, that is p of 11, becomes 0. Now in the place of x, when I substitute 11, the polynomial becomes 0. Now therefore, so at what value the polynomial becomes 0? At 11, the polynomial becomes 0. Now we can say 11 is the zeros of the polynomial. Zeros of the polynomial is nothing but at what value the polynomial becomes 0. Here we have found that at 11 the polynomial becomes 0. So this is what we are going to solve in this exercise. Now this is the first subdivision. P of x is equal to 3x plus 1. X value is given as minus 1 by 3. So in the place of x, we have to substitute this value and check whether the given value is a 0 of a polynomial or not. Okay. Now in the place of x, in the place of x, I am applying minus 1 by 3 is equal to 3 into minus 1 by 3 plus 1. Okay. Now 3 into minus 1 by 3. We can divide 3 and 3. So finally we have got minus 1 plus 1. Minus 1 plus 1 is equal to 0. That is p of minus 1 by 3 becomes 0. Now the polynomial becomes 0. Therefore we can definitely say this given value is a 0 of a polynomial. So yes, minus 1 by 3 is a 0 of polynomial of x, p of x. Second subdivision is p of x is equal to 5x minus pi. X value is given as 4 by 5. Here in the place of x value, we are applying the given value which is mentioned in the question, that is 4 by 5. Now you can understand clearly. Now 5 into x. So in the place of x, again 4 multiplied by 5. Okay. Now you know that 5 and 5 can be divided. It will be equal to 1. So now finally we have got 4 minus pi. Now we can see 4 minus pi is not equal to 0. We can write p of 4 by 5 is 4 minus 5 is not 0. Not equal to 0. Therefore, x is equal to 4 by 5 is not a 0 of p of x. The third subdivision, p of x is equal to x square minus 1. Here we have got two values for x. One is 1 and the next one is minus 1. So now let us substitute the first one, which is 1. In the place of x, I am substituting 1 here. Okay. So now x square, which is 1 square minus 1. 1 square is 1 only, minus 1, which is equal to 0. Now p of 1 is equal to 0. Let us check for p of minus 1. P of minus 1 is minus 1 square. Minus 1 square is x square minus 1, which is equal to minus 1 square is minus 1 into minus 1, which is plus 1. Okay. 1 minus 1, which is equal to 0. Now p of minus 1 is also equal to 0. For both the values, we have got the polynomial as 0. Therefore, 1 and minus 1 are the zeros of p of x. Now let us do the fourth subdivision. P of x is equal to x plus 1 into x minus 2. Now we have got two values to substitute. One is minus 1. Now let us substitute minus 1 instead of x. Here in the place of x, I am substituting minus 1, which is equal to. Now in the place of x, I am substituting minus 1. So the first x, it will be minus 1 plus 1. And inside the bracket, again there is x minus 2. That is minus 1 minus 2. Now minus 1 plus 1 is 0. Okay. Into minus 1 minus 2 is minus 3. 0 into any number is 0. Now p of minus 1 is 0. Now let us check for the next value, that is p of 2. Now let us substitute 2 instead of x. P of 2 is equal to x plus 1, that is 2 plus 1. Next is x minus 2, 2 minus 2. Now it is 2 plus 1 is 3 into 2 minus 2 is 0. Again 0 into any number is 0. P of 2 is equal to 0. The same as the previous one. For both the values, we have got the polynomial as 0. Then both the values are the zeros of p of x. Fifth subdivision is p of x is equal to x square. Here the given value is 0 for x. Now instead of x, we have to substitute the given value, which is 0. Now 0 square. 0 square is 0 only. Then p of 0 is 0. Yes, given value 0 is the 0 of p of x. Sixth subdivision is p of x is equal to lx plus m, where the given x value is minus m divided by L. Here instead of x, we are substituting minus m by L. Okay. Now Lx, L into x. In the place of x, again the same value, minus m by L plus m. Here we can divide L and L. It will be 1. Now minus m plus m. Negative value and the same positive value, when you add it, it will be 0. Now p of minus m by L becomes 0. Therefore, minus m by L is the 0 of p of x. Seventh subdivision, p of x is equal to 3x square minus 1. Here we have got two values. One is minus 1 by root 3. So let us substitute the first one here. In the place of x, minus 1 by root 3, which is equal to 3 into x square. Now x is minus 1 by root 3, the square. Okay. As this is square here, we have to simplify this. 3 into minus 1 root 3 square means into the same value, minus 1 by root 3, which gives us minus 1 into minus 1 is plus 1, divided by root 3 into root 3 is 3. So now we are substituting 1 by 3, which is the value of this square, minus 1. Now 3 divided by 3 becomes 1, which is 1 minus 1. Again we have got 0 here. P of minus 1 by root 3 is 0. Now let us substitute the second value, that is 2 by root 3. P of, in the place of x, we are substituting 2 by root 3. 2 divided by root 3, which is equal to x square, that is 2 by root 3 the whole square, which is equal to 3 into. Now simplify 2 by root 3 square, which is 2 by root 3 into 2 by root 3, which is equal to, multiply this, 2 2s are 4, divided by root 3 into root 3 is 3, which is 4 by 3 minus 1. Now divide 3 and 3. 4 minus 1 which is equal to 3. Now P of 2 by root 3 gives us the value as 3. Now 3 is not equal to 0. Now this is not a 0 of the polynomial, whereas the first one is definitely a 0 of the polynomial. So we can write like this: minus 1 by 3 is 0 of P of x, whereas 2 by root 3 is not a 0 of P of x. This is how we can give our reason. The last subdivision, 8th one. P of x is equal to 2x plus 1. The given x value is 1 by 2. Now substitute 1 by 2 in the x value, which is equal to 2 into x. 2 into 1 by 2 plus 1. Now we can divide 2 and 2, which is equal to 1 plus 1, which is 2 here. P of 1 by 2 is 2, which is not equal to 0. Therefore, the given value is not the 0 of P of x. Question number 4. Find the 0 of the polynomial in each of the following cases. These are the given subdivisions. In the previous problem, they have given a value to check whether it is a 0 of a polynomial or not. Now here, they have not given any value. You have to find for which value the polynomial will become 0. So let us start with the first subdivision. P of x is equal to x plus 5. Now what we are going to do is, polynomial of x, we are equating this polynomial to 0. The given polynomial is this. Now the same polynomial we are equating to 0 to find the 0 of the polynomial. Now when LHS are same, which means the RHS is also same. Okay. Now what we can do is, we can write x plus 5 is equal to 0 because both are same, which means the right hand side is also same. Now we have to find the x value. What is the x value? X is equal to plus 5. When you transpose to the other side, it will become minus 5. Now x is equal to minus 5. Now this is the value. This is the 0 of the polynomial. So when you substitute x is equal to minus 5, then it will become 0. Let us check whether it is correct or not. The given polynomial is x plus 5. In the place of x, we are substituting minus 5 plus 5. Okay, minus 5 plus 5. We know it is equal to 0. Then definitely x value is minus 5. So this is how we have to find the answer for the rest of the subdivisions. Before proceeding the second one, you have to write the answer like this. X is equal to minus 5. Therefore, minus 5 is the 0 of the polynomial. 0 of the given polynomial P of x. Now let us proceed the second. P of x is equal to x minus 5. Now the same way, equate it to 0. Okay. Now left hand side is same, which means RHS is also same. X minus 5 is equal to 0. We need the x value. So transpose this to the other side. Minus 5 becomes plus 5. X is equal to plus 5. Now 5 is the 0 of the given polynomial. 0 of P of x. Now the third subdivision. Third subdivision is P of x is equal to 2x plus 5. That is, P of x is equal to 0. Therefore, 2x plus 5 is equal to 0. We need only x value. Let us transpose 1 by 1. The plus 5 becomes minus 5 here. Now, we don't need 2x. We need only x. This is always 2 multiplied by x. If there is no symbol given, which means it is a product, which is multiplication. Now, x is equal to minus 5. Now, transpose this number. So, multiplication becomes division. X is equal to minus 5 by 2. Now, we can say, therefore, minus 5 by 2 is the 0 of P of x. Fourth subdivision is P of x is equal to 3x minus 2. Again the same, P of x we are equating to 0. Consider only the RHS. 3x minus 2 is equal to 0. We need only x value. 3x is equal to minus 2 becomes plus 2. X is equal to 2 divided by 3. This is the x value. Now 2 by 3 is the 0 of p of x. Fifth one, p of x is equal to 3x. Again the same. P of x is equal to 0. Equate the RHS. 3x is equal to 0. X is equal to 0 divided by 3. 0 divided by any number is always 0. Therefore, x value is 0. Now we can say 0 is the 0 of p of x. The meaning is, in the place of 3x, here 3 multiplied by 0 gives us 0. Okay. Now 0, x value is 0. That is 0 is the 0 of p of x. Next subdivision, p of x is equal to ax, where a is not equal to 0. This is the given condition. Now equate the same polynomial to 0. Ax is equal to 0. We are equating both the RHS. Now we need only x value. X value is 0. A becomes division here. 0 divided by any number is always 0. X is equal to 0. Now this is the answer. Therefore 0 is the 0 of p of x, like the previous one. Now the last subdivision. Given polynomial is p of x is equal to cx plus d. Now we can do the same. Equating to 0, RHS cx plus d is equal to 0. We need only x value. Transpose this d to the other side. Cx is equal to minus d. Now we need only x. X is equal to minus d by c. This is the final x value. Now we can say, therefore, minus d by c is the 0 of the given p of x, polynomial of x. I hope you must have understood both the sums we have solved in this video. See you in the next video. Until then, take care. Bye. Keep practicing.